Hey everyone, we're all using AI pretty much every day now to write, to create, to figure things out. But have you ever stopped to wonder how a model like GPT actually thinks? Well, today we're going to go beyond the hype and find out exactly what's happening inside the machine. Right? It's this incredible tool we use to draft emails, write code, even just kick around new ideas. But what is really going on inside that digital black box to create text that sounds so human? That's the mystery we're here to solve.
So, here's how we're going to break it all down. We'll kick things off with the absolute basics. Then we'll look at the three main blueprints for these models. And after that, we're going to zoom way in on the one that powers your favorite chatbots. We'll see how it works, who's building them, and how they're changing our world, before we wrap it all up with the single most important takeaway.
Okay, first things first. Let's start at the very core of it all. What even is a language model? You can think of it as the powerful engine that's driving this entire AI revolution. And this right here, this is the key to everything. At its heart, a language model is basically a prediction machine. It's been trained on a truly massive amount of text, like a huge chunk of the internet. And its whole job is to look at a string of words and make a really, really good guess about what word comes next. It sounds simple, but the results, well, they're kind of world-changing. But here's where it gets interesting. It turns out there's not just one way to build these prediction engines. There are actually a few different blueprints or architectures, and each one is built for a totally different job. This table breaks down the big three. First up, you've got causal models, and GPT is the famous one here. They're all about text generation. They only look at the words that came before to predict the next one, kind of like a storyteller spinning a yarn. Then there are masked models like BERT. Think of them like a language detective. They can see the entire sentence at once, past and future, which makes them amazing at understanding context and classifying things. And finally, you have sequence-to-sequence models like FLAN-T5. These are the expert translators, designed to take one whole thing, like a sentence in English, and turn it into another whole thing, like that same sentence in French. Now, for the rest of this explainer, we're going to focus on that first one, the causal model. Why? Because this is the architecture that's behind all the generative AI tools that have completely taken over. So let's see how it actually builds a sentence from scratch. And this right here, this is the aha moment. The reason these models feel so natural is because, well, they kind of work the same way our brains do. They process information in just one direction, from left to right, just like you're reading this sentence at this very moment. Every new word just builds on what came before.
So, how does it do it? Well, you can think of it as a simple two-step dance. Step one is tokenization. The model takes your sentence and chops it up into little pieces, kind of like Lego bricks. These tokens can be words or sometimes even just parts of words. Then comes step two, the actual prediction. The model looks at the sequence of bricks it's got so far and calculates the most statistically likely brick to snap on next.
Let's make this super simple. Imagine you type in, "the weather is." The model has seen that phrase millions, maybe billions of times in its training data. So it knows that words like sunny, cold, or rainy have a really high probability of coming next. It picks the most likely one, let's say sunny, and then it just does the whole process over again with the new, longer sentence.
So this super simple but incredibly powerful idea, well, it's being put to work by all the big names in tech. Let's do a quick flyby of the major players who are building these things.
You're going to recognize these for sure. Of course, you've got OpenAI's GPT family, which is the most famous, but then there's Google's Paul and Meta's Llama. But what's really exciting, I think, is the rise of these powerful open source models like GPT-Neo and GPT-J. It shows that this isn't just a race between giants. This tech is becoming available to everyone. And for any of you who are coders out there or just a little bit nerdy like me, check this out. This is literally what it looks like to use one of these models. With a standard tool called Hugging Face, a developer can tap into a powerful model like GPT-2 with just 2 lines of code. It's absolutely wild. All right, so we've covered the how and the who. Now let's get to the big one, the where. Where are you actually seeing these causal models pop up in your daily life? The short answer is, well, pretty much everywhere. I mean, just think about it. They're writing the blog posts and marketing copy we read online. They're the brains behind the chatbots and virtual assistants on our phones. They are completely changing software development with tools like GitHub Copilot. They're helping artists brainstorm new ideas, and they're transforming education and creating incredible new tools for accessibility. The impact is just massive, and it is growing by the day. Okay, we have covered a ton of ground, from high-level ideas all the way down to a few lines of code. So let's boil it all down. If you're going to remember just one thing from all of this, what should it be?
It's this all of that complex, mind-blowing, and sometimes spooky good human-like behavior you see from tools like GPT. It all boils down to one simple, elegant process: just predicting the next word. It's an idea that mirrors how we think, and it is the engine behind this entire tech revolution.
You know, at the end of the day, these models are just a reflection of us. They learn from our words, our code, our stories, our ideas. Which leaves us with a pretty big question, doesn't it? What are we going to teach them next?